1 squared is 1. I love the enthusiasm. 2 squared. 4. 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 100. Okay, I think it's pretty safe to say majority of us have to 10 squared pretty solid, right? All right, let's keep going. We need to know all of these. 11 squared. 12 squared. Good. 13 squared.
169.
Look at Chase knowing his squares. 14 squared. Oh, Chase, you let us down. 196. Do you guys know the trick between 13 squared and 14 squared? You're just switching the 6 and the 9. So 169, then 196. That's the only way I was ever able to memorize those. All right, 15 squared. Anybody know 16 squared?
2. No.
No, 2.
256.
256. Good job, Adam. All right, there's 2 more we need to know. 18 squared.
324.
324. Good. And 20 squared, which is 400. Yep, 20 squared is 400.
My mental math.
No, these are the ones that are going to be showing. I just pulled the ones that are going to be showing up a lot to have you have them memorized. All right. So the first thing we're going to talk about is simplifying radicals. But before I start discussing simplifying radicals, I just need to make a little note between simplifying radicals versus solving by taking the square root on both sides of an equation. So solving square root method versus simplifying radicals. If we have, let's say, something simple like x squared equals 16. So if we have x squared equals 16, there's 2 different ways. There are 2 different ways to solve this equation. The first way you can solve this equation is by factoring. So you bring that 16 over, so we get x squared minus 16 equals 0. And then that is a dots, a factoring, difference of 2 squares factoring. So this becomes x plus 4, x minus 4 equals 0, and then you solve by setting each parenthesis equal to 0. And you end up getting x equals negative 4 and x equals positive 4. That was one way of solving this. The other way you can solve that same exact equation, x squared equals 16, is called the square root method, meaning I'm going to take the square root of both sides. To undo a square, we can take the square root. So when you take the square root of something, you're asking yourself, what number times itself gives us the number underneath the radical? What number times itself gives us the number underneath the radical? So square root of x squared, what number times itself gives me x squared, or what variable times itself gives me x squared? X, right? But now, what number times itself gives you 16?
4 plus minus.
You got it. Positive and negative 4. Because isn't positive 4 times positive 4 a positive 16? But isn't negative 4 times negative 4 also a positive 16? So this becomes plus or minus 4. Didn't we get plus minus 4 both ways, by factoring and by square root method? Right, so when you're solving, when you're taking the square root to solve an equation, you must account for positive and negative values. But when you're just simplifying a radical, meaning there's no equation, there is no solving for a variable, we only consider the positive side of things. So, for example, when I just say my directions are to simplify, there's no solving here. Simplify the root of 16. If we're just simplifying, the answer is just 4. The square root of 16 is 4. Just simplifying. All right, what about the square root of 196? What is that? 14. No more radical, right? It's 14 times 14 gives us 196. All right. Is 27 a perfect square? Meaning, is there a number times itself that gives us 27? No. So how would I tell you to do something like this? My suggestion is to start making factor trees, but it's not about breaking it down to primes. It's about finding pairs. What do I mean? So let's break down 27. What multiplies to 27? 9 and 3. Then we break down further because there's no pairs here, right? 9 and 3, they're not the same. So now I'm going to break down 9 into 3 and 3. Now, the whole point of doing this is to get twins. We do not want triplets. We just want twins, meaning I don't circle all 3 of them because they're the same. We only want 2 of a kind. So there's our pair. There's our set of twins. What you're going to do is the pair that you circle, I circled 1 pair of 3s, right? Whatever you circle is going on the outside 1 time. Since I circled 1 pair of 3s, there's 1 3 that's going on the outside. Whatever's not crossed out and not circled goes on the inside. So what's left to go on the inside? A 1 3. So this reads 3 root 3. 3 root 3. All right, ready for another one? All right, number 4, root 24, again, is not a perfect square. So we're going to break down 24. Our goal is not primes. Our goal is pairs. So there are a lot of factors of 24. Some are better than others. For example, 6 and 4 is our best option, but I'm not going to do the best option. All right, let's do a lesser option. Let's do, I don't know, do you guys want to do 2 and 12 or 3 and 8? What would you have done?
I would have done 6 and 4.
6 and 4 is good. Okay, so I'm going to do 2 and 12. And then 12 becomes 2 and 6. Do I have a pair? Yes. All right. Now, if I break down 6, is there any way to get another pair? No. If you know that, don't break it down. But let's say you forgot. Let's say you just got factor happy. So then you broke down the 6. That's fine. So then you broke down the 6 into 2 and 3. Can I stick that 2 and make it a triplet? No, we only want twins, no triplets. So what do we get here? Whatever we circle goes on the outside 1 time. So I circled 1 pair of 2s, so that means 1 2 is going on the outside. Now, whatever we didn't circle and didn't cross off goes back on the inside of the radical. So I have a 2 and a 3 going back on the inside. What should I do with that 2 and 3? Multiply them. So this becomes 2 root 6. Was it okay that I circled from different branches? Absolutely, it's okay to circle from different branches. Are we ready for another one? All right, 34, the root of 34. Well, isn't 34 just 2 and 17? Are there any pairs there? No, so what's the root of 34? Just root 34. It's already simplified. What have I done with number 6? What have I added here? A negative number. It's called a coefficient. I've added now a coefficient. This reads -3 times the root of 28. That's really what that is representing, -3 times the root of 28. Just like 3x, isn't 3x 3 times x? All right, let's bring down 28. What are you all thinking for 28? 2 and what? 2 and 14. Sure, we could do 2 and 14. And then, oh no, yes. And then 14 becomes 2 and 7. Is it okay to circle from different branches? Absolutely. All right, how many 2s are coming out? Just 1 2 is coming out. What's already on the outside? a -3. What do you think you have to do with that -2 and that -3? You got it. We're going to multiply them. A 7 is left on the inside. So this gives us -6 root 7. I want you guys to do number 7 on your own. Try number 7 on your own. All right, so how did you guys break down 17? What was your, I'm sorry, 72. What was your go-to? 8 and 9, sure, that works. All right, and then 8 becomes 4 and 2, and then 4 becomes 2 and 2. Should I break down the 9? Absolutely. If you can get pairs, you should break it down. So then 9 becomes 3 and 3, which is another pair. All right, so what's going on the outside? Well, we already have a 6 on the outside. How many 2s are going out there? 1 2 is going on the outside. How many 3s are going on the outside? 1 3 is going on the outside. Anything left on the inside? 1 2 is left on the inside. So with all those outside numbers, you should multiply them. 2 times 3 is 6. 6 times 6 is 36 root 2. All right, number 8. Do we all agree 256 is 16 times 16? Isn't that a pair? Right. So there's a 10 on the outside. 1 16 is coming on the outside. Is there anything left on the inside? No, nothing's left on the inside. So our answer is just 160. No more radical on the inside. All right, we're going to skip these independent and we're going to go into adding and subtracting radicals. Oh, actually, you okay? Yeah. Okay, so let's go to adding and subtracting radicals. Adding and subtracting radicals is very similar to adding and subtracting variables. What do I mean? If I have a 3y plus a 4x, can I add them? No, why? They don't have the same variable, they're not like terms. It's the same idea with radicals. If I have a 3 root 2 plus a 4 root 3, the number underneath the radical is called the radicand. Right? If the radicands are not the same, you are not allowed to add or subtract them. Right? But if the radicands are the same, very similar to variables, if I have a 3x plus a 4x, what does that give us? 7x. Don't you just add the coefficients? All right, same idea. If I have a 3 root 2 plus a 4 root 2, all you're going to do is add the coefficients and leave the radical the same. All right, are we ready to do some problems? All right, guided practice number 1 here. What coefficient is really in front of these radical 3s, these root 3s? 1. So what's 1 root 3 plus 1 root 3? 2 root 3. You got it. All right, number 2. Can I add 4 root 5 plus 3 root 7? No, their radicals aren't the same. Their radicands are not the same, so we cannot add them. So this is just 4 root 5 plus 3 root 7. It's already simplified. All right, what about number 3? 8 root 2 plus 4 root 2. Connor?
12 root 2.
You got it, 12 root 2. All right, what's the problem with number 4? What's the problem with number 4? Erin? Excellent. They all have different radicands, but can these radicands be simplified? Absolutely. Radicals are like fractions. If you can simplify, you must simplify. So let's go ahead and simplify 18. I would probably start with 9 and 3 for that. And then 9 and 2. And then 9 becomes 3 and 3. So root 18 is 3 root 2. Where are you guys thinking for the root of 20? Where are you starting breaking that off at into? 4 and 5 is a great option. And then 4 is 2 and 2. So we get 2 root 5. Can I simplify just root 5? No. Out of all 3 of these, which are the only 2 that I can combine? Olivia. You got it. What is a 2 root 5 minus a 1 root 5? Root 5, you got it. So now that 3 root 2 just gets brought down. So you have 3 root 2 plus 1 root 5 or just root 5. If you want to put the 1 there, that's fine. It's just not necessary. All right, I want you guys to try number 5 on your own. Try number 5 on your own. Okay, let's say you did 96 the long way, okay, which is fine. And let's say you said, okay, well, I can do 3 and 32, right? And then you decided to break 32 down. What multiplies to 32? 8 and 4. And then you broke 8 down into 2 and 4. What would I hope that you would realize right now? The 4s. We don't need primes. We do not need primes. What do we need? Pairs. We do not need primes. We need pairs. So that means I have 1 4 going on the outside. Isn't there already a -1 out there? So this just becomes a -4. But what are the 2 numbers left on the inside? 3 and 2. What is that? Do I add them or do I multiply them on the inside? Multiply them. So it's going to be -4 root 6. All right. For 600, what are the 2 best factors for 600? Anybody know? The 2 best factors. James. 6 and 100. Why are 6 and 100 the best starting factors here? Because 100 is a perfect square, which gives us 10 and 10. If you remember, the goal is not primes, our goal is pairs, then you get through things a lot quicker. by trying to get the pairs right away. So now I'm going to bring a 10 to the outside. Is there any point in breaking down the 6? No, because I can't make any more pairs. So then this is going to be 110 on the outside and then a 6 on the inside. Can I add -4 root 6 plus 10 root 6 together? Absolutely. And we get 6 root 6. I want you all to try number 6 now on your own. Try number 6. And then we'll move on to multiplication. Other than Sophie, did anybody else miss my test yesterday? Everybody else was here for it? Okay. We ready? Who wants another minute? Okay. So 175, what are we breaking that into? Good, 25 and 7. 25 is a great choice because 25 is a perfect square, which gives us 5 and 5. So this becomes 5 root 7. All right, what about the root of 28? Who's breaking that down for me? Connor.
I broke it up into 4 and 7.
Good, then what'd you do, Connor?
Paired the 2's to break out of 4.
Perfect, so then what'd we get?
I got 2 root 7.
You got it. So we have 5 root 7 minus 3 root 7 minus 2 root 7. Can we simplify all 3 of these? Yeah, so let's go 2 at a time. 5 root 7 minus 3 root 7. Do we agree that's 2 root 7? But then you have 2 root 7 minus 2 root 7. What's that? 0, not root 7. 2 minus 2 is 0, not 1. So this becomes a 0 root 7. But if you were to write 0 root 7, I would take points off. Because isn't this really 0 times root 7? And what's 0 times anything? 0. So your final answer has to be 0 here. Root 7 is wrong, and 0 root 7 is partial credit. All right, can we move on to multiplying? All right, so again, multiplying radicals is very similar to multiplying variables. What do I mean? So if I have a 3x times a 4y, do they need to be the same variable to multiply? No, they don't need to be the same variable. If I have a 3x times 4y, isn't this 12xy, the product? Same idea with radicals. You do not need the same radicand to multiply. So if I have a 3 root 2 times a 4 root 3, all you're going to do is multiply the outside numbers. 3 times 4 is 12, and then multiply the radicals. Root 2 times root 3 is root 6. And then you would simplify if you can. No pairs in 6, so we just leave it like that. All right, let's do these. All right, this first one I'm going to spend some time on. Root 6 times root 6. What's root 6 times root 6? Root 36, but what's the square root of 36? 6. So do we agree root 6 times root 6 is whole number 6? All right, this is going to play a very big part in tomorrow's lesson once we get to dividing, multiplying a radical times itself. So let's do some investigation. You don't need to write this down. What's root 5 times root 5? Radical 5 or whole number 5? Whole number 5. Why is it whole number 5? Because root 5 times root 5 is root 25, which ends up being 5. What about root 7 times root 7? Any guesses on what that final answer will be? Whole number 7. What about root 100 times root 100? Whole number 100. What about root 1256 times root 1256? 1256. What do I want you to realize here? Whenever you multiply the same radical or square a radical, what do you end up getting? The whole number that's underneath the radical. So anytime you multiply a radical times itself, it ends up just becoming the whole number that's underneath the radical. No more radical. Right? That's going to play a big, big part in tomorrow's lesson. All right, negative root 5 times negative root 7. What I want you to do is multiply the coefficients. Do we all agree these coefficients are negative 1s? So what's negative 1 times a negative 1?
1.
Positive 1. Do I need to write a positive 1 coefficient? No. What's root 5 times root 7? Can I make pairs out of 35? No, so we just have root 35. All right, let's keep going. Root 3 times root 4 is root 12. Can I simplify 12? If I can simplify, do I have to? Yes. So 12, I would do 3 and 4. And then 4 becomes 2 and 2. So this ends up becoming 2 root 3. All right, what about negative root 5 times root 10? What do you get for that one before simplifying? Negative root 50. How are you choosing to simplify 50? Perfect. And then 25 becomes 5 and 5. And this becomes negative root 5, I'm sorry, negative 5 root 2. All right, number 5, 2 root 2 times 3 root 18. We're going to multiply our coefficients. 2 times 3 is 6. Then we multiply our radicals. 2 times 18, do we agree that's 36? And isn't 36 6 times 6? Pair. So I have a 6 on the outside. 1 6 is coming out from our pair. Is there anything left to be in the radical? There's nothing left for the radicals, therefore there is no more radical. What's 6 times 6? 36, no more radical. All right, you all do number 6 and then we'll go over it. Okay, let's go through. So I multiplied my outside coefficients. Negative 5 times negative 3 is a negative 15. Then we're multiplying our radicals. Root 22 times root 2 is root 44. We need to break down the 44. So I would have gone with 4 and 11, and then 4 is 2 and 2. 1, 2 is coming out, but there's already a negative 15 out there. So what is 2 times a negative 15? Negative 30.
I think it's supposed to be positive 15 on the outside.
Oh, you're right. Thank you. Negative times a negative is a positive. Look, I was just making sure you're following along. All right, and then we have an 11 on the inside.
Sure.
Uh-huh. Guys, I can't be perfect all the time. All right, number 7. So we have 3 root 5 raised to the second power. Now remember, anytime you're raising something to the second power, you're just multiplying it times itself. So 3 root 5 times 3 root 5. So start off how we always do, multiply our coefficients. 3 times 3 is 9. Please do not disappoint me here. What is root 5 times root 5? Not Adam, he had it last time. Somebody else. What's root 5 times root 5? Bridget. Whole number 5. No more radical, right? Anytime you multiply a radical times itself, it ends up just being that whole number. 9 times 5 is 45. No more radical. All right, our last section. So sometimes it's easier to multiply than simplify, and other times it's easier to simplify than multiply. So for example, root 64 times root 49, a lot easier to simplify than multiply. For this one, it makes perfect sense. Why? Because 64 and 49 are both what? Perfect squares. So 64 is 8 times 8. There's our pair. Take one out. No more radical. 49 is 7 times 7. There's our pair. Take one out. So then we're left with 8 times 7, which is 56. Now, other times, like number 9, these are not perfect squares, but if you were to multiply then simplify, 90 times 48, wouldn't that be a really big number to try to start breaking down? So sometimes it's easier just to simplify it first so the numbers aren't that large. So for 90, what are you all thinking for 90?
9 and 10.
I like 9 and 10. And then 9 becomes 3 and 3. Is there any point in breaking down the 10? There's no point because there wouldn't make any pairs anywhere. So this would just be 3 root 10. And then 48, what are you thinking for 48?
12 and 4.
Sure, 16 and 3 would be our best option, but let's go. I like 12 and 4 because I think most people would do 12 and 4. So then 4 becomes 2 and 2. Can I stop there? No, why am I not allowed to stop there? Because we can make more pairs with the 12. So then 12 becomes 3 and 4. And then 4 becomes 2 and 2. So then what number is going on the outside and what's going on the inside?
4 root 3.
4 root 3. Because you have 1, 2 from this pair going on the outside, but then you have another 2 from this pair going on the outside. So it's a 2 times a 2, which is a 4, and then a 3 on the inside. So we are 4 root 3 times 3 root 10, which is going to give us 12 root 30. If I break down 30, will I get any pairs? No, so we stop there. All right, number 10. Whenever you have a number and then parentheses, what do you have to do with that number? What is it called? Starts with a D. Distribute. Good. We need to distribute. So right now, it doesn't matter that it's a radical. I still need to distribute. But be very careful. Is that first 5, is that a radical? No. So root 3 times Whole number 5 is not root 15. What is root 3 times whole number 5?
5 root 3.
Excellent, Chase. 5 root 3. And do not disappoint me here. What is root 3 times root 3? What is root 3? Not Bridget, not Adam. Mariana? Whole number 3. You got it. Can I simplify or combine this or do anything else? No. This is as far as we can go. All right, number 11. 2 root 3, we're distributing again, times 5 root 6. Remember, multiply the coefficients. 2 times 5 is 10. Root 3 times root 6 is root 18. Then I have 2 root 3 times 4 root 5. 2 times 4 is 8. Root 3 times root 5 is root 15. Is this my final answer? Good. James, what should I do? Good. We can simplify root 18. So we got 2 and 9. And then 9 becomes 3 and 3. So we get 30 root 2. Can I get any pairs from 15? No. So then it's just plus 8 root 15. Can I add a 3 root 2 and an 8 root 15 together? Can I add them? No, they're not like terms, right? They don't have the same radicand. So we just leave it like this. All right, we are done for today. Your homework, if you scroll down, is this next page and numbers 1 through 16. And you could probably get it done now. We're all done.